Hey guys, it's Off51 here, and today we're going to be solving Maximum Product Subarray. In this problem, we're given an integer array nums, and they want us to find a subarray that has the largest product, and then return the product. I think the best way to approach these kind of problems is by writing out the examples and seeing if we can find a relationship between the numbers. So for example here, we know that 2 and 3 is our max product subarray, and we notice that these are all positive. So the first criteria is going to be we want a lot of positive numbers. And number two actually is what if we had another negative at the end here? Well, now our max product subarray is going to be this whole thing because -1 times -2 is going to turn into a positive. So we want an even amount of negative numbers. So how can we use this information to figure out some kind of algorithm for this? So if we look at this, we see that 2 times 3 is 6, and let's just store that in a variable called max. And then we go to the next number. 6 times -2 would be -12. So we're not going to update our max with that. And then now we just multiply -12 times 4, and that would give us -48, and that's definitely not a max. But once we approach this new number, -1, we see that multiplying it would give us 48. So that would be our new max. So what we see here is that our max could come from either a positive integer or a negative integer. So we want to keep track of our maximum, and we want to keep track of our minimum. So that way we can multiply them and compare them later. To make the relationship a little clearer, I'm going to go through another example. So here we have -1, 2, and 3. And let's just start out with -1. So once we go here, we want to check if this is a min. And since it's the first object in the array, then it is going to be that. So our min is going to be set to -1. And our max is also going to be set to -1 because that is still the greatest integer. And from here, we're going to go to the next one. And what we're going to do with this is check if this is our new min, check if this is our new max, and check if this times the min or this times the max will give us a new min or max. So I know that was a lot of words, so let me just write it out. So this is basically what I just said written out, and we're going to set our new min equal to the min of our current number times our previous min, and our current number times our previous max. And same thing for the max, except now instead of min, we're just looking for the max here. So let's just go through the array where we left off. So we were at 2. We already have our previous min and our previous max here. So our current number is 2, and then 2 times our previous min, which is -1, and then 2 times our previous max, which is -1. And we see that our min here is -2, so we're just going to update that. And then our max is going to be 2. So now we go to the next number, 3. Our current number is now going to be 3. Our current number is now 3, and our previous min is -2. So now we're multiplying that, and current number is 3 multiplied by our current max, which is 2. So our min here would be -6, so I'm going to update that, and our max is going to be 3, or 3 times 2, so this is greater, and that is 6. And that's going to be our max product subarray. So just to make sure that this algorithm works, in case there are 2 negative numbers, let's add a negative number here at the end. So if we go to this number, we see that our current number is -2, our current number times our min, and then our current number times our max. And we see here that the min would be -12, so we're going to update that. And we see that our max now is going to be 12, because -2 times -6 would be 12. So now our new max product subarray would be all of this, and that's exactly what we're looking for. So now we can get into the code. I've written a comment here to explain the time and space complexity of this algorithm. The time is O of n because we're only looping through the array nums once, and the space is constant because we're only going to be using a few variables to keep track of our min and max. So first, for the code, we just want to write our variables, and we're going to have previous min and previous max. And this is how we're going to keep track of our products. And then we also want to have a global max, and that's going to be set to -infinity to start. And then from here, we just want to iterate through the whole nums array. So for num in nums, what we want to do is get our min and get our max. So our current min is going to be set to this formula here, and then our current max is going to be set to the same formula, but instead of min, we are just looking for the max. And then from here, we just want to check if our global max is less than our current max, and if it is, we just want to update it. So global max will now equal our current max. And then from here, we just want to update our previous max and previous min to whatever our current one is, so that way our next iteration will be able to reference it. So previous max is equal to current max, and previous min is equal to current min. And then that's basically the whole algorithm. After that, we just want to return the global max, and we can just submit the code now. So as you can see, the code is pretty efficient, and now I'm going to go through it manually. So to start, we just want to set our variables up so we can keep track of them, and I've already done that here. And then now we're just going to iterate through the array. So for every num in nums, so our current num is -1, we want to calculate the min and max from these three variables. So num by itself, num times our previous max, and num times our previous min. So I've written it out here just so we can see it a little clearer. So num is just -1. Num times our previous max is -1 times 1, and that'll give us a -1. And then we're going to have -1 for previous min as well, because that is also 1. So our current min is going to be set to -1, and our current max is going to be set to -1 as well. And then from here, we just want to check if our global max is less than our current max, and it should be because our global max is -infinity. So we just want to update that to -1. And then now we just want to update our variables so the next iteration can access our min and max. So our previous max is -1, and our previous min is -1. So now we go to the next number, 3. So our current number is going to be 3. Our current number times our previous max is going to be -3 because it's -1. And then our current number times our previous min is also going to be -3 because it's also -1. And then from here we can see that our max is going to be 3 and our min is going to be -3. So we just want to update these to -3 and 3. And now we want to check if our global max is less than our current max. Current max is 3 and our global max is -1, so that's true. So we're going to update it to 3. And then now we just want to update our variables again to keep track. So we're going to have previous max equal to 3 and previous min equal to -3. And now we go to the next number, -2. So we have -2, and then -2 times our previous max is 3, which is -6. And then our current number times our previous min is going to be -3 times -2, which is +6. So we can see here that our max is 6 and our min is -6. So our max is going to be 6 and our min is going to be -6. And now we check again to see if our global max is less than our current max, and it's true because it's currently 3, but our current max is 6. So we're just going to update that. And then now we just update the variables of previous min and previous max. So our new previous max is going to be 6, then our previous min is going to be -6. So now we go to the last number here, -2 again. So -2, and then -2 times our previous max is -2 times 6, so -12, and -2 times our previous min is going to be +12. So we can see here that our max is 12 and our min is -12. So we're just gonna update these. And now we're gonna also update global max because it is less than our current max. And we're gonna update these variables, but since this is the last iteration, we don't really need to do that, but just gonna do it for demonstration's sake. And then now we just return our global max, which is 12. And we can see that that is the correct answer because by looking at the subarray here, we can see that that returns 12 because 3 times -2 times -2 is 12. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.